I am going to discuss about the branching instructions call and return in assembly language for microprocessor 8085. Before we talk about the branching instructions call and return, we need to know what are stacks and subroutines. Let's talk about stack first. A stack is a group of memory location in the read-write memory that is used for temporary storage of binary information during the execution of a program. Usually the starting location for the stack is defined in the main program and the space is reserved usually at the high end of the memory map. As you know, this has a very good advantage that when we start the stack from the end, there is a lesser chance of the program overlapping with the stack memory. This is the example of how we can initialize a stack pointer. It's LXI-SP2099H. This defines the location of the stack, and the storage of the data begins at the memory address that is one less than the address in the stack pointer register. In this case, the storing of data begins at 2098H and continues is in reverse numerical order. The point to be noted here is that we have initialized the stack at 2099, but the storage begins at 2098H. When we will deal with memory addresses in 8085, which are 16-bit, the stack pointer is decremented by 2 while the data is written to it, and it is incremented when data is retrieved from the stack. Now the subroutines. As you know, a subroutine is a group of instructions written separately from the main program. It usually performs a function that occurs repeatedly in the main program. A popular example can be the delay instructions, which tends to occur many times in the program, but we can write it only once, and then we can call it from the main program whenever it is needed. In the 8085 microprocessor, we have call and return instructions to implement subroutines. The call instruction is used in the main program to call a subroutine, and the return is used at the end of the subroutine to return to the main program. We need to note that when a subroutine is called, the contents of the program counter, which holds the address of the instruction following the call instruction, it is stored temporarily on the stack, and the program execution is transferred to the subroutine address. I will show how it is done later on through an example program. When the return instruction is executed at the end of the subroutine, the memory address stored on the stack is retrieved, and the sequence of execution is resumed in the main program. Now here is a sample program that would explain how the call and return statements are executed. Here the starting address is at 2000. The first command, LXI-SP200H. What it does is that it initializes the stack pointer at 2400H. Now the next command is at 2040 location. This is called 2070H. It calls a subroutine which is located at the memory location 2070H. So at this point, the program counter holds the address of the next instruction, that is the memory location 2041. So before that the execution is transferred to the subroutine, the stack pointer stores the location 2041. Now the subroutine is written at 2070. Now since the execution is transferred to 2070, the execution continues, and when it encounters the return instruction at 207F, the stack pointer pops out the data that is 2041, and the normal execution of the program resumes. As you note here, that the stack is initialized at 2400H and it continues in the reverse numerical order. The benefit is that the stack does not overlaps with the normal program. This is the sequence of the program execution. It began at 2000. When it reached 2042, it encountered a call instruction, and the execution was transferred to the subroutine which was at the memory location 2070, as you can see here. Now, after it encounters a return instruction at 207F, the execution resumes at 2043 and the normal sequence proceeds. This is how the call and return branching instruction work in a 8085 microprocessor.